All right, g'day everyone. So I'm back. What I've done is I've moved that little SDR that we saw like a few videos ago onto this board. Now you'll see that there's a big blank space free here. Well, the idea is I copy one of these, but I'll kind of explain it as I go. So to start off with, there's the VFO. It is ugly, yes, but it is a VFO. It oscillates somewhere around 7122 kilohertz, something like that. I also do have a 7812 linear power supply on there just because I really would like a stable reference voltage. That would be good. So as you see, 13.8 goes in. Hang on. 13.8, yeah, something like that. It's kind of a standard voltage. And I am producing, well, 11.63 out, but that is very consistent with this. This is some budget 7812 voltage regulator, so obviously there's something not quite right with it, but it does seem to be stable even over a large voltage range. So that's all I really want anyway. Anyway, you'll see VFOs over this side that I just showed you before. You can't really see in the video. I do have a antenna input, pre-selector, RF amp. So there's 2 transistor RF amp there. They aren't the max gain type, so there's 4 resistors per transistor. I'm getting about, I don't know, something like 30 dB or something there. Into obviously double balance mixers, you'll see 4 little diodes in a little ring there. There's 2 mixers because this is a phasing radio. So this mixes the 71, well, I'll actually put in a frequency, 7121 kilohertz. Turn that on. And hang on, I've got the level way too high. Let's go down to negative 73 dBm, huh? Negative 73 dBm. And you'll see it's not quite triggered properly. Let's go down to, there we go. I don't think that noise that you see there is real. I think it's probably just a bad earth. But anyway, this is pretty low signal level. You see 11 millivolts, so it's not exactly a lot. I can see it's not triggering properly either, so let's just move the trigger point. Hang on, where's there? Where's the trigger point? Let's trigger it somewhere. Oh, there's a bit of noise. That's why it's not very stable. Yeah. Anyway, that's to be kind of expected with this low signal level. So this is an S9 signal, and as you see, yeah, maybe not the prettiest, but I think that actually is more to do with this oscilloscope meter than anything else. I do want to just check a few voltages. So obviously, I do have my 11.63 here. Coming out of this should be also 11.63. However, these RF amps and the audio amp have a 100 ohm resistor to kind of short away RF and make it a high impedance load for the RF. And then I short it down with, disc ceramics. So on the RF amplifier, we'll have a look at the voltage there. It should be less than 11 to 10.1. And on the AF amplifier, 11.23. The RF amplifier does have more current going through it. I do want to check a few nodes. So I want to check the collector of this. 4.82, it's kind of in the middle of the range, it's not so bad. And this collector over here, 5.3, it's okay. Check the collectors of the audio amplifier. Should be, hang on, that's the base, isn't it? Yeah, that's the base. 7 volts, that's all right. And the collector here, 7 volts, all right. Obviously, you lose a little bit through the transistor, so it's all good. Hang on, come on. Oh, apparently you don't lose much. Geez, okay, hang on. 7 volts there. Oh, that's because that's the same leg. That's all right. I forgot my circuit, didn't I? I'm looking at the emitter, which is usually a little bit less. Anyway, radio. This circuit is working. So this is a 7121 kilohertz signal, and I've got 1 kilohertz coming out of here. Now I'm going to up the level because this is S9, and actually friends are kind of actually around S9 plus 10, maybe 15. So that's S9 plus 10. I think this actually, I don't think that's real noise. That might be There might just be bad probes or bad probing, one of the two. Anyway, there you go. There is our signal. So that's 63 dBm at 121. So this is actually below the carrier. You'll see that yellow leads the blue. If I go to 7123, because the carrier is on 7122, you'll see something very interesting. So 7123 kilohertz. And then we go up and down dB because, okay, well, it's still not triggering properly. Come on, scope, what you doing? Maybe just trigger off the other channel. Yeah, this is kind of not very stable. Anyway, the point is, you can see that now the blue leads the yellow. And if we have a look at our XY graph, you'll see a circle. So, you know what? I'm nearly 100% sure that this is actually noise getting picked up by something. I don't think that's real noise. I'm going to try and move these scope probes away from whatever it is. Yeah, you can see it kind of changing there. I'm nearly 100% sure that that noise isn't real. So I'm going to dangle the leads over here, get them away from whatever it is. All right, whatever, doesn't matter. Yeah, I don't know if that noise is real or not, but anyway, what we can do is obviously we've got more dynamic range. So the problem I was kind of having before I even recorded this video, actually we'll go up to about 200 millivolt range. Oh, 100 millivolt range should be okay. Now, if I keep pumping signal into this, so we'll go S9 plus 20. Hang on, that's modulation. I don't want to go to modulation. Go back, please. Another 10 dB. That's fine. Let's go another 10 dB. This is S9 plus 30, so this is negative 43 dBm. I don't know if you can see that in the... No, you can't. It's kind of blown out. Anyway. This is S9 plus... Yeah, 30 dBm. Looks all right still. We'll go to the XY plot, have a little look. Hang on, that's not what I want to do. It is a little bit distorted. You can see it's kind of squishy. Yeah, it's a lot easier to see in the XY plot, isn't it? This is my little diodes here. So I've got back-to-back diodes, so they will voltage limit the signal to 600 millivolts. Obviously, I'm hitting that now. So S9 plus 30, and I'm already kind of having, I wouldn't say overload issues, but issues. If I keep going, this is S9 plus 40. Hang on, I'm just off scale there. That's not real. We'll go to 200 millivolts division. Now we go back to our XY plot, which is here somewhere there. It's not very much of a circle, is it? Anyway, I'll switch over to the computer. I've actually kind of recorded the computer part already because this first part of the video was trash. So there you go. I built another receiver and I'll switch over to the computer and do some testing. Okay, so this is the computer side of it. Now, our little radio makes our audio source, and we can immediately assume that that is a complex signal now because we have the I in the Q, so it is a complex signal now, and then that makes the rest of this really easy. This here is our VFO. We got some displays of the waterfalls, and a pen adapter is the frequency sync there. Now we have a choice of whether to frequency or filter from negative 10 hertz to negative 3 kilohertz or 10 hertz to 3 kilohertz. So this is a lower sideband and this is the upper sideband selector. And yep, there we go. That's how you select the which one you want. You ignore the imaginary component, but you can use either the real or the imaginary component, but we're just going to use the real because it doesn't matter. I do AGC it, so there's a bit of automatic gain going on, and then send it to our speakers so we can hear it. So we'll start it up. I do have this thing, okay, all right, on 131500. So that will be producing obviously this tone we can hear here, and we can just scroll along the radio. This here would be the center frequency nonsense, and then we should hear this here is the opposite sideband. So that's this signal. This is because this is not a perfect SDR. I do have, what are we at? Negative 50 here. On down here, we are negative 80. So we've got about 30 dB sideband suppression, which is, it's fine. It's okay. It's better than nothing because, yeah. But anyway, what I can do is I can attempt, well, actually, no, hang on. What I can do is I can attempt to change the signal level. So we'll knock this down to, let's say, 93 dB. So we'll chuck off 20 dB a signal. Now, we're still listening to this sideband over here, and it's barely in the noise floor. You can't really see it anymore, but obviously up on 132. Oh, hang on. Oh, this here, frequency shifting, is actually the tiny SA. It's really not perfect. So let's go 713.200. That's interesting. I don't know why it shifted here, because we haven't... Oh, I've shifted the program. Hang on. I might have scrolled it or something. Yeah, there we go. There's 7132, so that's okay. Still there. So this is our VFO. Our signal's still there. It's negative 70 dB on the scale, and that is a negative 93 dBm signal. We'll keep going, so let's go to 103. Still there. A little bit harder to hear because, I don't have the infinite gain on this AGC, but it's still above the noise floor. Go negative 113, 115. Still there, but yeah, you'd be hard pressed to kind of come across that. That's not a very good signal. But this is not why this radio exists. This radio exists because I have a radio group, and generally everyone is S9 plus 10. So we'll go to negative 63 dBm. Ow, my ears. The AGC is not working properly. Hang on. I will fix that. I'm going to close that. I think this rate's wrong. I don't know what this rate should be, but that hurt. Okay, we'll try that again. All right. It's got a bit of a frequency wobbly thing going there, but yeah, okay. Yeah, that's all right. All right, we'll put our frequency back on 132. Now what I'm going to do is, actually, I really don't need to hear that. I'm going to pull that down. How can I do that? I can do it in the recording, but you know what? I'm just going to do it in editing, I suppose. What I'm going to do is I'm going to bring the VFO to, let's say, 124 here, and then I'm going to start clipping it. So let's change the frequency. So 7124 kilohertz. We will go down. You know what? Actually, we don't need the audio for this. Or maybe. Who cares? All right, we'll start clipping it. So we'll go up to like S9 plus 20. You can start to see these little spikes appearing. S9 plus 30. It doesn't sound exactly clean, does it? And you can start to see all these friends appearing in the spectrum. So this, they're all about 1 kilohertz or so off each other because of the VFO, and then this is just sideband suppression failure. So these here are the friends, I believe. So I'll keep going. Now we get stronger friends. It's off the scale there. 125, 127, 129, 131, 133. They're about 2 kilohertz off the VFO. And you can see this is what happens when you start clipping an SDR. I'm going to go all the way I can. This is as much signal as the tiny SA can put out. It's negative 20 dBm. As you can see, things have lost the plot. Anyway, but that's not really a real signal I think I have to care about. So we'll go back to like negative 70, 83, something like that. Anyway, you get the idea. It's not the most beautiful SDR in the world. Actually, it kind of had a lot of frequency drift there when I was playing around down there. But you get the idea. It does the thing. So yeah, don't really have anything else to say. I still think possibly I have too much gain. And maybe when I added those diodes, maybe I should have added two in series, so had a little bit more range. But yeah, that is. I suppose that's what happens, huh? Alrighty. I wonder if I can just temporarily add another sync. I think there's a oscilloscope time sync. Time sync. I think this is it. If I do this, I think, and get rid of this temporarily, this should be a different type of output. I don't know what this is like. Oh yeah, there we go. There's our signal. This is the actual audio signal coming into the computer. So obviously a little bit more signal is needed. We'll get the VFO where it doesn't really matter. You can see here, start hearing some friends and stuff. It doesn't seem to be triggering at all, but it's whatever. I'll keep going. Let's go up. This looks all right. Keep going. Modulation none, please. Keep going. There you go. Now you can start to see it looks a little bit yucky, how it's rounded on the ends. This is the diode clipping at 0.6. So to me, that actually says the computer's reference voltage is around 1 volt. And obviously, if I keep going, if I keep pushing this thing up to negative 18 like it was before, come on, where are you? Up here somewhere. You'll see that it's just like, yeah, square. So that's the diodes doing the job just to protect the computer, but I might have too much gain still. Anyway, there you go. There's there you go. I suppose that's kind of all I have. That's just me testing how I test, how I build, and what I make, and yeah, just having fun, I suppose. All right, I'm going to Control Z this so I can put my other things back and get rid of that. Don't really know where to go from here. I think I've got to hook this up to a real antenna and see if I've got too much gain. And if I do, then I'm going to change the probably the audio amplifier, get rid of some more gain there, and call it a day. I think I'm pretty sure the audio amp, the mixer, it's got such a strong VFO that it's not going to overload the mixer. It's definitely the amount of gain I got in the audio. Alrighty, have fun, everyone. That's kind of all I have. It's a bit of a ramble of a video, but that's what I've been up to. All right, catch you later.